Yeah, can you hear me? Can you hear me? All right, I'll try one more time. I'll just keep talking for a while. Okay. Was that a yeah, you can hear me, or yeah, keep talking? Okay, sorry. You came. You've been entertaining all day. Like this, that's perfect. Thank you. What? Y'all just let me know when to kick it, or is it running out? Are we good to go, or do you? Oh, my bad. All right. All right. So what we're here to do today is talk about next level management and delivering always ready containers in an ever evolving platform. That's a ton of words. I hope that is the most complex part of this entire presentation. Put quite simply, we have the ability to move workloads, and we should do it. There's definitely benefits of doing it, and we're going to hopefully explore those today, how we do it, how we make it easier, and so on. So, start things off, Ryan Cook. I am Cook the Ryan at everything, so you can email me at Red Hat, Twitter, GitHub. I am the lead of the platform team with the emerging technologies. The nice thing about platform is we have the ability to kind of bleed into everything. So I feel like our group is the most spoiled. We get to play with storage, security, the platform itself, containerized environments, Kubernetes. So I'm sorry the rest of y'all that are in here that you have teams, but I just feel very lucky. So why are we here? We often talk about our platforms, Kubernetes, OpenShift, Podman, and they're just delicate. We can't touch them. We have these maintenance windows that are at obscene hours of the night. We can't update them, or we only update on Fridays, and we don't want to actually touch them. But practices exist already today, and things coming in the future that are going to make it so that you can move smoothly. If there is an amazing deal on a cloud provider and you want to move there, it's as simple as pushing a couple buttons or changing config file within Git, and you're actually using that platform. And I kind of want to compare this with like my toddler today. If I ask her what her favorite thing is, or favorite food, she's going to tell me pizza. If I ask her 10 minutes later, she's going to tell me popsicles. And so I want y'all to be able to say, X is my favorite platform. My on-prem data center is my favorite platform. My Equinix Metal is my favorite platform. We shouldn't be scared to explore other platforms because it's difficult, or well, we're already in, we should be able to move things. We should be able to make things happen and be agile with it. So we have the tools, we have the talent. You guys all have amazing engineers. We can get there. So to start things off with, we're going to cover a couple best practices that are things that you guys can do today or probably are already doing. Best practices around images. The best part about UBI is that it's available for your users running Fedora and so on. So you can build these images using the UBI Red Hat image. And they offer this amazing UBI minimal that is very small. They patch it very frequently. Also, sign your images that you're running in your containerized environment. The reason why I say that is we've seen a lot of supply chain interruptions or images that may have gotten picked up along the way that don't have the things that you expect to have in them. And so signing those images gives you that verification that, yes, this did come from our build system or somebody's name is actually on it. If you're interested in that topic, Luke's going to be talking about that right after this. And then also vulnerability scanning. I called out two of them here, specifically Trivy and Quay. Quay does a good job of taking a look at the packages within your system. Trivy will actually take a look at your binaries and see that, oh, with your Go binary that you're choosing here, runc is vulnerable to this issue. The next item, and this is what I really want to drive home, and multi-arc images. Even if today you're just Intel-based, AMD-based, 64-bit, just this is how I live my life, go ahead and just create those ARM images. And the reason why I say that is it costs your build system maybe an extra 10 minutes. Tooling exists for it today to be able to just do it, and you push the manifest up, and you see the two little penguins there, and that just means that this image itself has multiple architectures. And the reason why I said that is, so say for example, I have this hardware here, Intel NUC. We've seen some crazy things with supply issues this past year. Say for example, you can't get an Intel NUC, but you can get a Raspberry Pi. If you have that ARM image already built, your GitOps system already identifies and knows that image, you're often running on that hardware. So how to build them? Build a bud, the build a project, can build multi-arc images as well as Podman. And then lastly, if you're a user of GitHub Actions, there's a nice one called Docker Push Action. And what this does is it builds all of the architectures that you provide for in the GitHub Action, packages the manifest up, and then adds it into your registry, such as Quay, Docker Hub, etc. And then your multi-arc. And literally, it is not that much work to implement even the Docker push action and add an architecture. And then another point I want to bring up is the best practice is GitOps. And so what GitOps is just a fancy way of saying every asset that I deploy within my environment is stored in Git. Tooling applies the objects on the intervals and just makes sure your environment is in a state that you expect it to be, and the fact that when you update your environment with it, that asset is sent to Git and then sent to your various environments. So define it once, deploy many. Taking a look here, we just have like an example of what a repository looks like. As you see, here's a Kubernetes deployment in a service. So the nice thing is you see, your image defined here. So when you go ahead and make that update or you build a new image of your application, you update this image tag. And then the best part is if you're multi-arc, you really don't care that it's O2 demo. It's just going to deploy wherever because you have that manifest that defines, your ARM-based and your Intel-based image. So it just makes it really cool, and it just gets you prepared for that what if. What if I need to use an architecture? And then, looking at some of the work that Waman Chin's team is doing around sustainability, what if my workload is better supported or better suited for a different architecture? All right, so let's talk new. Let's talk the future. Let's talk about what's happening now. So today we're going to talk about two projects in regards to platform. The Fetch It project, which we're going to focus on Podman specific items of how you can maintain and manage a container lifecycle. And then we're going to introduce you to the idea of KCP. KCP is going to handle our OpenShift Kubernetes ideas and a whole lot more. So let's start things out with Fetch It. So the idea behind Fetch It was that Kubernetes has this amazing set of tools to lifecycle your container, to do pretty much everything you need to do around images. We saw that with that deployment YAML that we showed a minute ago. But what if you're just running Podman? What if your factory, what if your location has two containers? You don't want to really have to make the full investment into Kubernetes. So what if I want to just use Podman? but there isn't some like slick, fun tool like around it to handle the lifecycle for you. So that's where Fetch It kind of came in. It's GitOps driven, as we kind of showed a minute ago. Hosts interact directly with Git. So put it this way, this Intel NUC you see here will reach out to Git and identify the assets that are supposed to be running on it, check in and make sure that they are in fact running on it, and then deploy them if not. And then rather than, an intermediary or your office, your headquarters contacting your edge nodes, wherever in the world they may be, and deploying assets. We utilize the Podman Go bindings. So the nice part about this is we get to offload some of the difficulties. The Podman team produces these Go bindings. We actually just get to utilize what they've created, what built, to interact directly with the Podman socket. As I said earlier, not Kubernetes dependent, and you have the ability to lift and shift hardware. I'm going to risk it all here in about 5 minutes and show a demonstration of lifting and shifting hardware. I have this amazing setup of, this is my router for the entire presentation. This is going to be running an application, and it's going to break, and then we're going to plug this one in, and our application's still going to be there. So pretty much what we're trying to show is with that is that we have the ability to recover without a lot of effort. So we'll talk about the various methods before we go into the demonstration. We have the prune method, which if you're talking about these small devices at the edge, you want to be able to clean up after yourself. If you did 10 deploys a day, you might have some stale images out there. So we do this by running the Podman prune. We also have an Ansible method, and what this does is it runs an Ansible playbook against localhost and applies what is needed or what's defined in the playbook. Systemd, and what this actually does is it places the systemd file in on the system, enables it, starts it, activates it, and gets it off and running. There's two other methods remaining. The raw method, this is like the equivalent if you're like on the local system itself and you're running podman run -d my various container, environment variables, and so on. It's like the most simplistic. And then lastly, the cube method. And so the one thing that I want to mention about the cube method is, I'm not sure if anybody's played with Podman PlayCube, but all right, so it's kind of really cool. Podman introduced the concept of allowing you to run Kubernetes-based objects in Podman. So what that means is you could take your deployment that you have running in your Kubernetes cluster, run it on your system, patch up that deployment YAML as you need to, and then ship it back to your Git repo to be ran on your Kubernetes cluster. The nice thing about that is we're going to take that cube method and we're going to build off of it from Podman going into Kubernetes and KCP. So here is a very small font of all of the methods in action. These are on the GitHub page. But you see a general consensus of how they work. There's a schedule in which it operates, and then you define a target path of where your GitOps-based asset lives. And then pretty much all it does is run on a cron-based schedule and applies as needed. This one is the coolest feature of it all, and I will hopefully show that here shortly. Configuration. So what this actually means is I can have a bundle of these Intel NUC-based systems, and I place this file into a directory. Once it becomes online, it's actually going to go and check out the URL to figure out what it's actually supposed to be. And then the cool thing about that is we don't have the ability to get stale. We don't have a stale configuration that's going to be applied because it's actually reaching out to Git and saying like, hey, what am I supposed to actually be at this time? And so, as Bart would say, we are going to run a live demo. There's no safety net, and we're running off my phone. So here we go. So we're running a demo application. All right, so if we go to app. I know, right? All right, so we have this demo store application. It's just a simple site that's running from our NUC, and I want to take and go ahead and upload a picture to it. This is something that you would think about within a factory automatically occurring, An image is taken at the factory, uploaded to a system, and then it is analyzed either back at headquarters or machine learning events happen. Sorry, the text is very small in this. All right, so we're uploading our picture now. All right, cool. So if we take this and go to photos, we will see a picture from the last presentation from Raghu talking about the, inflexibility, and hopefully I took this picture because hopefully we're helping to resolve some of that inflexibility. So as you see here, we're running the application on this NOC. We can upload photos to it, exist, and fetch it is actually running on the system. So what we need to do now is we're going to actually define a new application to be added in. So taking a look at our configuration, we see that we're using the cube method, and what that means is we're deploying a Kubernetes-based file onto our Podman system. We're going to add in a new application. We're going to call it name, hello, target path, hello, and schedule. Thank you for that. All right, so what we're going to do is, Erin is sitting up front, and I can see her, so hello, Erin, everybody. All right, so what we're going to do is we're going to serve a deployment of a Alpine image, just serving a simple index HTML. It says, hello, Erin. And what we're going to do is we're going to update this, and we're going to update the configuration file, and we are going to send it to Git. So save this. Okay. All right, cool. So to spice it up a little bit, let's just go ahead and pull off power now and see what happens. So we're going to rip the power to this one. As you see, we're replacing with this one with the kissing hand sticker from my daughter. And I'm going to power it on. So what we're going to expect to see here is we're going to expect to see this reach out to Git to see that our file for our configuration has changed, defined as so. So we're going to have two applications then running on that system. And then the next step of that is we're going to see that that hello application is actually there. So let's go here, we'll ping app. We'll wait for it to come online. All right, cool. So this is coming online now, and Podman is actually running in a systemd file. So it's going to run a systemd file. It's going to look at that config YAML. It's going to realize that it needs to go to Git to get the definition of what should actually be on the system, and then we're going to deploy it. So going over back to this, let's see if our assets have indeed deployed already. Okay, cool. So that one's actually already ready. And now I need to remember what I set the port for our hello application to be. It is running at 9001. All right, well, I either did not use VS Code correctly or it is waiting to grab that configuration file. So what we'll do is we're just going to go ahead and back to the slides. And an important item to pull out here is, what about a multi-architecture? I was talking about this in the beginning. It wouldn't be right if I actually didn't show the multi-architecture piece of it. So what we're going to do now is SSH to ARM shell. So we are ARC64, and if we do a podman PS, we see that our photo app does exist there and it's running. The cool thing is that if you look at this image itself, it doesn't say like ARM or anything crazy like that. It is just the ability to define an application one time, run it on whatever architecture that we need to define within Git using GitOps practices. So jumping back into the slideshow, we'll talk about KCP now. I warn you before we start, KCP is an elephant of an object, but it's going to provide so much for us in regards to how you interact with cloud.red hat, how you interact with items within multiple Kubernetes clusters. So managing workloads amongst multiple Kubernetes clusters is somewhat difficult. We kind of glue this together with Argo app of apps today. Rackham TM does an amazing job of this today in regards to multi-cluster applications, management of multiple clusters. Workloads might need to be available on a certain numbers in the fleet. How do we do this? And what about the difficult thing that is hard to really take care of? What about traffic routing, persistent storage? I feel like it's been years now where we talk about Kubernetes, and that last part we're just still kind of scared of, or we don't want to admit it's still kind of difficult, and that's persistent storage. So KCP in general, what actually is KCP? So KCP is a minimal API server that sits above your clusters and has the ability to look at resources based off of a workspace. So what does that actually mean? So I, as an administrator, can build a workspace that has clusters that are deployed throughout every cloud provider that I see fit. And if you think about managing that at scale, how am I going to go and run OC git deployment and try to actually figure out where I've done stuff? So the nice thing is that I can create a workspace and a series of namespaces under that workspace that are particularly special to me. Some may be particularly special to Luke, and so on. So it's kind of cool because it's multi-arc with some training wheels on it. We have the ability to help out SLAs because of the fact that we're going to spread the workload out amongst multiple clusters. We're going to kind of handle it for you. Then the last part is API extensibility through custom resource definitions, kube-like APIs. So that's a lot. Pretty much what that means is we can interact with things in a cube way that aren't, exactly cube. So we can interact with Podman if we write an extension for it. We can interact with libvirt if we write an extension for it. And then we use the standards that we use today of spec and status to be able to define things custom ways, and the fact that you get statuses back from it. So I can take a look at my libvirt cluster and see that, okay, cool, these hosts are running and I have a status, but I can do it in a Kubernetes-based way. So here was kind of what I was talking about earlier when we have the smart control panel, the KCP layer, the common control plane, and then we have a namespace, and then we have multiple clusters. The cool thing is it's spread out on its own. It's kind of handled by the KCP layer. Spreads workloads among clusters, and then the cool thing is when we talk about this, we get to work with smaller clusters, and we allow for kind of, from a systems admin standpoint, a way to actually manage these a little simpler, because if you have 60, 70 clusters and you're needing to do X, Y, Z, if you can just launch against that control plane, it might make things a lot easier. Apps can be assigned to specific groupings of clusters within that workspace. There is a concept called placement rules, similar to what you see with Rackham, to be able to say, I'd like to place my application amongst these clusters only that have, say, for example, a GPU. And then I think the other ability that's kind of nice is the ability to just take clusters kind of offline and online, and the workload is going to move for you, allowing you to do upgrades, to take them down and replace them, to, just to kind of do whatever you really need to do with hardware-based issues. Or even adding in temporary clusters to see, hey, what's the 4.12 update of OpenShift going to look like for my deployment? All right, so why am I personally excited about KCP? So there's a member of my team that's actually working on the storage piece of this. As I mentioned earlier, storage is absolutely hard. So storage migration, what we're going to do first starting out with is storage migrations on a shared backend. What we're talking about here is I have a OpenShift cluster that's connected back to the same OpenShift Data Foundation ODF cluster, and I can flip the workloads between there in a safe way. The next one is storage migrations between a non-shared backend or even different cloud providers on-prem. Yes, it deserves that emoji. Because what this actually means is I can go from my on-prem cluster where I'm running ODF to Amazon in the event that there's an event where I need to get actually out of my data center. And I can take that storage and that data with me. And that, I believe, is going to use the VolSync project, which has the ability to take data from one cluster to another using various methods such as rclone, rsync, and restic. Global load balancing functionality. This one is absolutely amazing. Pretty sure you probably stop Steven in the hallway later and talk about global load balancing because it is a very difficult topic, but we're hoping to bring this functionality within KCP. So what that means is, when your workload is floating between these clusters, moving amongst everywhere, you don't actually need an admin to update the GLB. If you add a cluster, it's already defined, it's already there. And then the last one is workload splitting and rebalancing. There was a demonstration of this at a KubeCon about a year ago, maybe. What this means is I can say that I would like 15 of my web pod running. I can do this amongst 3 clusters. In the event one of those 3 clusters goes offline, I'm going to rebalance that workload, and we're still chugging along with 15. So the rebalancing splitting is something that, in my opinion, is very huge because that way you get to expand the data, especially when we're talking about these small clusters. Huge caveat is some of these items are still in heavy development. They may work for a little bit, then may not work. They are planned and in progress and on the roadmap to be a thing. So let's walk through a little bit of KCP. All right, so the terminal, clear, exit. All right. All right. So I'm going to cheat a little bit. You guys are going to see my script slightly, but all right. So what we need to do is we need to start the KCP binary right now. So I will take this and I am going to export path. And I'm just exporting my path to give me access to the KCP binary and so on. So pretty much when you start KCP, you're going to get this like insane wall of text. And as you see, it's creating the custom resources that you expect. So when you run kubectl API resources, you'll see a list of items. I'm going to split this so that we don't get lost in the wall of text. All right, and all right, going back to my cheat sheet. All right, so I already have 2 clusters deployed. So I'm going to go ahead and in the KCP layer, I'm going to create a workspace. If you recall when we talked about workspaces, this is my personal workspace that will define any of the clusters that I have ability to send workloads to. So when the administrator sets this up, we will take and we will create a deployment of the Syncer application. And pretty much what the Syncer does is it creates a deployment as well as the proper permissions to be able to follow along with items that we deploy and report back a status. We'll be able to see that later on. So taking a look at that. So we have our 2 clusters already deployed. We are going to go ahead and deploy the Syncer deployment on them. So as you see, on those remote clusters, we went ahead and created the specific namespace for KCP, as well as the proper permissions to make it run. So that is all of the legwork in getting KCP running. Nothing like really crazy. As you see in the back end, the crazy is going on the left side. Going back here, we're going to take a look at our sync targets, which we will talk about in a moment. Okay, so sync targets. These are our two Kubernetes-based clusters that we have the ability to launch applications against. They're called sync clusters. So pretty much all we have to do at this point is use Kubernetes the way that we're used to using Kubernetes. And so if we do kubectl git deployment, we will see that this kguard deployment will come online momentarily, and it is online. So let's bring it all the way back to the beginning, where we talked about Podman and kubeplay and those assets that we used for the first demonstration. So if we do it, go ahead and do a kubectl apply. Hello. We will pull the hello application as well as our photo app. And so we were able to use the same application definition that we used for Podman in Kubernetes, and now we're actually deploying this in KCP. And so the last piece I'm going to show in a moment is we're going to just destroy one of the clusters that we are actually using for KCP. So I'm going to do this in tiny font because I just need to figure out where actually workloads are running at. All right, so it looks like our applications are running on our second cluster. So let me confirm that. That's weird. All right, let me try this when we're done. All right. Okay. Git. Okay, so it does look like indeed our applications are running on our second cluster. And so what we're going to do is we're just going to do what we're going to do now is we will actually see that our clusters are going to change and our application will move with it. So when we take a look back at our sync targets, that will fail in a moment. One thing I want to kind of pull out, talk about real quick is, I know that I kind of breezed through this when we were talking about it, but when we take a look at these IPI resources, it is a heck of a lot smaller list than you're used to seeing with a standard OpenShift environment. The fun part about this is that you can actually add in specific API resources that you may need. So if your company is into using Argo CD, you can go ahead and add the CRD for Argo CD in here, and then you can do OC git projects, and then take a look at your Argo CD amongst many clusters. So the nice thing is you can use existing tooling today, utilize the new placement and locations and sync targets that are coming within KCP to kind of take the complexity out of multi-cluster scheduling and placement for you. So just to wrap things up, let's take a look at deployments and our Hello applications coming back online. Our demo app is up. And so yes, we've officially moved from our KCP2 cluster all the way to the KCP1 cluster. So it is the workload migration without me actually needing to say, please move here in my git configure within Argo CD. So with that, I will pull up one last slide. and we will go to questions. The reason why I'm pulling up this slide is I know that times during conferences or even sitting in a room like this, it's hard to want to ask questions. So in the event that you have questions, or if there's something of interest to you in platform, if you have a random question about OpenShift, whatever, just feel free to reach out. I mean, if I don't know the answer, I will find somebody that knows the answer, or somebody that knows the answer. I'm here to help you out, because that's how I'm successful, is because if we can build this all together, we can solve these problems together, then it makes it easier for both you and I. So with that, we'll do questions.
How do you see KCP developing in relationship to ACM?
So the question, actually we'll read through, and we're in a small enough room. Okay. So in relation to ACM and KCP, I believe that in the future, and I believe the ACM team is already actually developing and working on this, we'll see that coupled integration begin to take place. Like I said earlier, the placement rules are very similar to what you see in ACM today. And so what I think is we're going to be bringing the KCP functionality, will bring just yet another layer to ACM today. And we'll be bridging that missing kind of bits between the networking piece and the storage piece today. So in my opinion, and from the few conversations I've had, it's going to be just an enhancement almost. So it's not going to change that experience, because, like I said, there's a couple of those items that are so closely linked that we actually just get to cheat and use them.
So with KCP and some of the examples you gave, just describing it as this abstraction of the Kubernetes interface, are there resources today that don't have sort of solutions out there that you think KCP could be applied to in the future?
Yeah, and so the nice thing about that is KCP, I believe, actually offers within their Git repository guidance on implementing those resources that actually aren't Kubernetes-ish today. You can add these into your environment, and as long as there's some sort of API or an agent that you can build around it, and then report back based those Kubernetes type status items, we can use it. And so when you think about like the extensibility long term of that, some of the possibilities are endless, which makes this project somewhat difficult, because there's so much space that we can do with it. And it's just the fact of doing it right and correctly. But yeah, there's, like I said, if you have a socket for an application, for just a socket in general, even a Podman socket, Sally O'Malley with my team has actually written a KCP fetch it module that allows you to do KCP and Podman base management with fetch it today. So it's a really cool framework that allows KCP, that is, to bleed into other things as well.
Thank you.
There's a question from Ola. The workload migration is easy. What areas of workload migration do you think still needs work? And what is the biggest area for changes needed?
So I think in regards to what areas still need work, what's really difficult for migrations is, some of the back-end work. Like, so say, for example, if your site needs a VPN to connect between the cloud services. Right now, there isn't, I'd say, a clean bridge of creating that relationship, that secure tunnel to resources that you use today. And that's where some of that uncoupling of, well, my application needs to be connected to my home HQ for X reason, even if there's not X reason, even if it doesn't make sense, but that's just how we operate. So some of the legacy ways that we approach ideas or things, are going to possibly change in the future. The fact that bringing legacy and then bringing new together are always difficult. And then I think, as well, storage is so much difficult as well, because although, you will be able to move applications between OpenShift environments, there's always that, well, do I mirror my application based off of the software provided today? For example, taking a Postgres cluster. Do I use the Postgres cluster software itself, or do I use, Vault Sync or something like that? So those are questions that I don't think any organization will have a clean answer for, of which one's the best to use. And so those are the hard questions, because we can't really confidently answer how they wanted to mirror their data or stay in sync.
Another question from Ola. Can KCP be combined with deploying WASM images to form an ultra-small, lightweight case cluster?
That I don't know. That would be, hopefully, an amazing emerging technology solution. I have a feeling, especially I'm sure Jim can attest, that WASM is going to be the future of something. And KCP is definitely going to be the future of interacting with Kubernetes-based APIs or interacting with APIs. If there's a way to get them to talk to each other, I'm sure someone will do it. It's just a very early emerging item. All right. Anything else in chat?
I have a question.
Cool.
Mention of GTM. Is the GTM external to KCP? So it's like an F5 GTM that can be reconfigured automatically?
So I know that the team that is running this is initially working with cloud load balancers first, and then I believe they will move towards accessing those on-prem F5s, Big IP, so on. Your various at-home data center-based network solutions. The nice thing is most of those systems include an API to interact with that. So I think it's something that can come. It's just we're kind of, I believe, MVPing based off of cloud solutions, because those are the easiest for us to kind of interact with and develop really quickly, and they're kind of very already proven in regards to modifying the flow of networking or adding a new entry into the various DNS providers or load balancers and so on.
About the global load balancer, is that around all the clusters for one deployment across, even if it is like multiple clouds?
So that is the goal, because if you think about it, we would want anything within our workspace that has a route defined for our deployment or application, we would want it to be accessible. What that looks like at this point, I believe, is still heavily under development, and I don't know if that's actually going to look like a different custom resource, or if they will be able to piggyback routes with that syncer that we saw earlier, the syncer that we added to the cluster, and then it would go up and modify resources. So it actually just kind of depends. There's still a lot of work to be done in that space.
So Oleg is asking, you mentioned Fletchit and Kubeplay for performing Kubernetes deployment. What would be an ideal workflow that would like to emerge from the Fletchit project?
Okay, yeah, a nice workload from that would be, in my opinion, regardless of what method you use to update your application, I'm thinking, so say for example, I push a security fix to my application, which in turn builds a new image. Once that image is built, tagged with a git sum or git hash, I would like to then update my deployment file or my fetchit configuration for raw, or at least just the image definition for the application. And so to me, that's either a Tecton-based task that is going and pulling your Git repo, making the change of the image ID, and then just shipping it back up, or a GitHub action that is doing roughly the same thing, where we're building our image, and then we're publishing that asset back to the Git repository, which in turn makes everything hands-off, because that's the whole, kind of goal of what we're doing here with the GitOps, and as well as these different platforms. We build the image, it automatically updates, it hopefully is signed along the way, and the asset is updated within Git, and it's all hands-off. So at the end of the day, the developer only has to worry about updating their code, and that they know that that application is going to get out to the multiple edge clusters, or as many clusters as they need it to go. As we saw here with the demo today, accessing, hitting the SNUC as well as the Azure resource, or cloud resource, that is. All right, again, feel free to reach out about any questions you have. Definitely here to talk if you guys pass me in the hallway or see me around. So thank you all so much for attending. What? Oh, yeah.